Welcome dear students. Today we will learn the analysis of a fixed beam subjected to couple at center by this flexibility matrix method. So now in the flexibility matrix method, the first step that already we know, that is the DI, that is degree of indeterminacy. Now if you neglect the horizontal or reactions, so it is RB, this is RA, and here the moment MA, and here moment MB. So these are four unknowns and our equations are the 2. So DI is equal to 2. It means we have to remove the two forces from this 4, that is this, suppose it's MB and this is MA. So MA, RA, RP and MB. So here we remove the moments. So release structure is in this way. It means we have to insert here the hinge. And this is the moment M at here. So this structure is called as the release structure. This is A and this is the B. So this structure is called as release structure. Now apply the rotations at A and at B. So this is our assumed direction, that is, suppose this is our direction of MA is like this and direction of MB is like this. So this is rotation at 1 and rotation at 2. It is a unit force or unit moment. Okay. So now we know the formula is dq is equal to dql plus F into the Q. dq is the initial displacement at coordinate 1, at coordinate 2, that is not here, 0 0. F is a flexibility matrix, Q is the unknown force matrix. So now first we will find the dql matrix. Here the dql is the action at coordinate 1 and at coordinate 2 due to this external moment. So that is the dql1 and dql2. This is the unit moment here now at 1 and at 2. So to find out this dql1, dql2, now we are using here the diagram. Multiplication method. Instead of direct formula, we are using here the diagram multiplication method to find out the dql and dql2. What is the procedure is to first draw the bend moment diagram due to the, this is the beam, this is the M. So BMD due to this external loading, so that is in this way. This is create hugging bend moment. So at center this is hugging bending moment M by 2 and M by 2. This is positive and this is negative. Now next step in diagram multiplication method is to draw the bend moment diagram for the rotation at the 1. So we are applying here unit moment at the coordinate 1 and this span is the here. So for this bending moment is here. So this creates the sagging bending moment. So and is 1 unit moment. So this is the positive, and this height is L, this length is L. So by using this diagram multiplication method, in this the formula is, if you want to find any, this is now rotation, so theta b, that formula is summation of am into this m small m. This is at b, so we write is here b divided by the ei. It means here area of the bend moment diagram, that is this diagram we also called as the m by ei diagram. So area of this m by ei diagram into the ordinate of m diagram at the center of this m by ei diagram. So here is the diagram 1 and diagram 2. So now dql1, that is equal to, now first step is to divide this figure is figure number 1, figure number 2. So area of this diagram, that is, this is minus, so minus 1/2 base into the height. This is the height. Now this is the two-third of L by 2 is the centroid of this x bar of this figure. Now transfer this distance to the here. So our aim is to find this y. So what is here? Area of this bend moment diagram multiply the ordinate in small m diagram at the center of the m by ei diagram. So now what is here? This is the distance we want from here. This is the 1, this is L. So we want this distance, so that is equal to its total is a L. So L minus 2/3 of this L by 2. So L minus 2/3 of this L by 2. This gets cancelled out to 2. So L minus L by 3. So this becomes 2/3 of L. Now this distance is 2/3 of the L. So we want this height y. So this y by symmetry of triangle, 1 divided by the L is equal to this y divided by 2/3 of L. So this y becomes the 2/3. So multiply here by the 2 by 3. What is it? This is the MB. It means ordinate in the small m diagram but at the center of the m by ei diagram. Now this is the first part. This is now then plus again the area, that is 1/2, then base into the height m by 2 ei. Now multiply here. From here the distance is the 2/3 of this L by 2. Okay, now transfer this distance to the here. Suppose this is now the y1. Now our aim is to find this height of this y1. Now, so this becomes here. Now what is here? Is 2 by 3 into L by 2 here. This is L by 3. It from here. Now this becomes L by 3 from here. Now if you draw L by 3 from this side. So now the calculations again. This 1 divided by L is equal to this y1 divided by L by 3. So this y1 becomes 1 by 3. Okay. So multiply here by the 1 by 3. So this total is minus ml by 24. So dql1 is equal to minus ml by 24. Now we have to calculate the dql2. So dql2, that we can say that now from the here. Now for this again you have to apply the unit moment at the 2. So in this case this pendulum diagram is similar to that first one. This is 1 and this is L, and our m by, this is a small m diagram, and again our basic diagram, that is the m by a diagram, is like this. Is a plus minus, this is m by 2 and this is m by 2. Now from initially in the case of dq, we have calculated from the here, that value is the minus ml by 24. Now we are calculating this from the here, so this automatically this value is the same and only the sign will be the change, that is ml by 24. So now we got the matrix of this dql, that is the minus ml by 24 ei. This is now, put it here, ei. Forget here the ei, and here is a plus ml by 24 ei. Okay, now the Q matrix, that is the unknown, the force. Now in our basic figure, this we given as number 1, number 2. So this m is the number 1, mb is the number 2. So unknown force matrix ma and mb. Now the dq matrix is the initial displacement at the coordinate 1 and at 2. So there is no sinking and no initial rotation any. So that is why this value of dq matrix is at 1 is 0 and at 2 is the 0. Now we got here the dq matrix, q matrix and dql matrix, and now remaining is the F matrix. Now for the F matrix, what is here is to apply the now you have to apply here this, how much is the, this is the now deflection shape, and this is the slope at I and this is the slope at the IB. So this is a 1, so use as F1. It's a coordinate number 2, we know this is the F2. We are applying the rotation at 1, so 1 and give this 1. So now due to this application of this unit rotation, the slope at developed is IA, and here the slope developed is the IB at 2, 1. So F11 is equal to, that we know is L upon the 3I, and F21, that is the F12, the application of this unit rotation at 1 will develop the slope at the 2, and that magnitude is L by the 6 EI. Half is developed here. then F22. It is here now. So now we are applying the unit moment at this 2. So this is 2, this is 1, application at 2, so 2 and 2. So this will, so this is now is IB here, and this is the IA. So this unit rotation develop the slope at 2, that is L by 3I, and will develop the rotation at the 1 is L by 6CI. So we got here the as usual matrix is L by 3EI, then L by 6EI, L by 6EI, and L by 3EI. So here we got all the matrix, that is DQ matrix, DQL matrix, F matrix, and the Q matrix. Now we put all this value into the matrix. So the formula is DQ is equal to DQL plus F into the Q. Now this is 0, we know. Now here is minus 1 by 24, and it is plus 1 by 24. We take it common, ml by the EI, then plus here 1 by 3, 1 by 6, 1 by 6, 1 by 3 here, and that is 1 upon EI into here MA and MB. Okay. So now if you take here MA, directly solve here MA and MB, that is equal to this is 0, 0 minus this, so this becomes plus and this becomes the minus. And suppose we do one more step here, 1 upon this EI into 1 by 3, 1 by 6, 1 by 6, 1 by 3, that is equal to this 0, 0 minus this minus 1 by 24 minus 1 by the 24 ml upon the EI. So now if you solve this, you take towards the right side, this becomes the inverse. This inverse, so this EI gets the cancel out now here. So this the final value of that matrix is EMA, that will be equal to, this is the L. So this also the L gets the cancel out. So the final value is the m by 4, and here is minus m by 4. So now we got the value of EMA is m by 4 positive. It means here assume direction of this one is now clockwise, so that MA is clockwise. So MA is equal to m by 4, and that value is correct. It means suppose if you draw here, this is the M, these are the fixed moments now. So this direction is the correct, and the moment is the m by 4. Now this value is negative. It means here we assume the in anti-clockwise fashion. So now we assume this rotation act in anti-clockwise fashion, but the value is the minus. It means our direction is wrong. So here this direction of this MB will be the clockwise. So these are the fixed moments, that is MA. So this clockwise movement produces this clockwise fixed moments. Thank you.